Okay, why we needed a new XML? We needed schematized XML input, schematized XML format. We need because the code doesn't work alone, works many times with other codes that need to exchange, and it interacts with these codes many times, exchanging its text, its output text files. And okay, no, this is the. So why we need a standardized input-output format? We need it because we need to implement a robust communication and storage mechanism of our text files that so we need to have a defined standard for how this format is described with this is provided by the XML the schema. Whenever a change is made in the format, these changes must be published immediately to everybody, and this is guaranteed by the way in which, by the fact that when we implement some change in the output, this change must be first written out in the format and then implemented. And also this allows, via Python tools, to have an automatic reader and writer synchronization. So any program that is reading data from Quantum Espresso text files will be able to synchronize automatically, thanks to the schema, to the modification that are put in the schema directly. By the point of view of the development and maintenance, it also gives some advantages because it's possible to use for the input and the output the standard libraries. Actually, not so many in Fortran because only Fox and IoTK are possible, but in other programs there are many of them, and so this is a great advantage for the reader at least. And from our point of view, we had the possibility to generate automatically most part of the source code for the implementation of the input-output. So this is the input, the XML schema for PW, and so we have a main root element which is called ESPRESSO. Inside this main element, we have further sub-elements. The principal ones are input and output. The input describes a complete input of Quantum Espresso. And this element is mandatory inside the schema. So every time that you have an input file, you have an XML file describing a computation with PW, it is possible to fully reproduce this computation. The other main element is output, which provides all the physical informations which are computed inside the computation. Actually, all the small data, physical information that can be put in a text file. The big data will be put in binary files. And then we have other small elements, sub-elements of the Espresso root element, which are parallel info and status, which provide information about how the computation terminated and about the environment in which the computation was run. Then for molecular dynamics and optimization, we have a list of other elements which are called steps, and each step provides a brief description of each molecular dynamics of optimization step. So there is total energy and other information inside it. So what is the status now of XML input, new XML input output in Quantum Espresso? It is still optional, and to test it, one has to compile the code with the configure option, which is enable XML, which will switch the main part of this the main consequence of this switch is that it will compile the PW restart new F90 file instead of the PW restart, and with this option you also activate or you also enable all the new input-output features of Quantum Espresso, about which Paolo was speaking before. How it works, this new XML input-output. Basically, by the user point of view, you just see that instead of the old data XML, data file XML, you print out you print output in the prefix.save directory a file which is called data file schema XML, which is an XML file described by the schema. This same file is actually also printed out in the autodir directory, and there it's called prefix.xml. Whenever an XML input file is provided at the beginning of the run, this same input file is copied verbatim in the final XML output file, and in this way the user can provide by himself the information about on how to run the computation. Otherwise, the program will generate this input element by itself. So the implementation consists in various parts. The basic libraries are called quest types module and quest libs module. The quest types module contains important data structure. Each of one describes the elements of which are present in the schema. For each one of these data structure, we have routines for writing and for creating, writing, and resetting these elements. Many of these elements can allocate dynamically data, so it's important that whenever one of these elements is created, it must also be destroyed, otherwise you will have memory leakage. These data are all produced in an automatic way by the code, by a Python code that reads the schema and creates these modules. A second layer of modules are the QE-XSD modules. We have three of them. One is QE-XSD module that provides all the routines that you need to fill the elements of the output, and also the routines to effectively write the XML file at the end of the run. Then we have the QE-XSD module, which instead makes the same work for the input element. We have a third element, which is called QE-XSD reader, where you have the routines that are needed to read the XML file, and the reader is used in PW restart new F90 and in a read file F90. So we have that the read file, where these routines are used, they are used in read file whenever you have to recover information from previous run to start a new calculation or to do post-processing. It would be important that every program that uses that reads information from Excel file should use read file in order to have an automatic portability of the changes to all the codes that read XML files. Then we have another place where the routines are used are at the beginning of the code in QE-XSD input init, where you initialize the input element from the variables inside the input parameters module, and in case that your file that you don't provide an input XML input file, the program will use this element and will print out it at the end of the run instead of the input file, the input element provided by the user. Then PW write schema. In PW restart new writes all the XML information at the end of the run, and so he uses these routines. Other points where these another point where these routines are used is at the end of each dynamic molecular dynamics step or optimization step. Each step element is initialized and memorized at the end of the molecular dynamic step, and these are allocated dynamically and are written at the end of the run. This avoids you to erase the file many times, but for large molecular dynamics run may cause some problem of memory, so maybe it's better to implement some option to write only one step on some mechanism with which you just print one step every some number of steps. And so other elements which are initialized at the beginning of the run are parallel info and status. They are, one is filled at the beginning of the run and the other at the end of the run. They are printed out in the end of the run. So, and then we have there is still an experimental module which is not in the trunk, which is not submitted in the trunk, where with warning and error messages. These are two. A dynamical list of warnings should be also put in the XML file to keep track of the warnings that the program gave. And in case the program exits with an error message, the error routine should be modified in order that the error routine also prints out the XML, an XML element where you have the error message. And so one important thing is when one wants to add new elements to the schema, one has to follow a little bit a cumbersome routine to do this. First of all, he has to modify the schema. This is important because if you first modify the schema, you are also kind of broadcasting to all the other users the modification to the output that you are doing. So these are automatically communicated to everybody. And this is important because in this way there is the chain between who is writing and who is reading is not broken. And you have to create the element, insert the element in the right position, and you have to also to modify the XML. If the new element is in the input element, you have also to remember to modify the XML to name list converter that allows you to create a name list from an XML file. The other thing that you have to do is to run, then after you have created your modified the schema, you have to run the Python module that generates the QS libraries and modify then accordingly the library, the QXD modules to write and read the schema, and then you have also to modify the calls to these routines which are inside the PW code. And so this is the ongoing work. We have to adapt the Python script to generate QS libraries which are compatible with the Fox libraries. We could also add inside the QS read some QS routines for reading elements directly in the input out in the QS libraries. So so generate them automatically, and also take care to replace all the calls to IOTK inside the code. And so other work which is going on is the implementation of schemes for phono, NEB, and CP inside the QE codes, and developing a scheme for pseudo-potential files. So the people who contributed to this work are, for the schemes, Antonio Zambon, Paolo Giannozzi, Mauro Palumbo, and Davide Brunato. The Python coding has been made mainly by Giovanni Borghi, Andrea Ferretti, and Davide Brunato. The Fortran part has been made by Andrea Ferretti, Giovanni Borghi, Simone Ziraldo, Paolo Giannozzi.